Let's begin now.
Hey guys, so we're still busy with stoichiometry, and today we're going to be looking at percentage purity, not to be confused with percentage yield or percentage composition. So, what is percentage purity? Percentage purity is how pure a sample of a substance is. Okay, that's straightforward. How pure a substance of a sample is. And we calculate this with the equation percentage purity is equal to mass of the compound divided by the mass of the sample multiplied with 100. Now, when do we use this? If we use a certain substance that we know contains most or is most or mostly consists of the compound that we want in a chemical reaction, then we can use the substance. But we first need to determine how much of the substance is actually the compound that I need. Or I'm saying substance, but you can also use the term sample. So in this case, where I'm saying mass of sample, I'm talking about the mass of the substance. Now, an example that you will come across quite often, especially like in the exam and so forth, is if we look at shells, the ones that you get from the sea, seashells, she shells. Now, these shells consist mostly of calcium carbonate. Okay. Now, our first example takes us exactly to that. It says shells contain calcium carbonate as well as other minerals. Farah wants to know how much calcium carbonate is in a shell. She finds that the shell weighs 5 grams, and after performing some more experiments, she finds that the mass of calcium carbonate and the crucible, a container that is used to heat compounds in, is 3,2 grams. The mass of the crucible is 0,5 grams. How much calcium carbonate is in the shell? All right, so let's first look at what do they give us. They tell us the mass of the sample, and in this case, it's the shell. So the mass of the sample was equal to 5 grams. And the mass of the compound, now here you just need to pay close attention to what they actually say. They say that the mass of the calcium carbonate and the crucible is 3,2 grams. And the mass of the crucible by itself is 0,5 grams. So to get the mass of the calcium carbonate, we have to subtract 0,5 from 3,2. So that's going to be 3,2 minus 0,5, and that's going to give us 2,7 grams. All right. Now we write down our formula. So percentage purity is equal to the mass of the compound divided by the mass of the sample. And obviously it's percentage, so we multiply it with 100. Now, if ever you are wondering which goes where, and it's not obvious, the smallest one goes at the top. Okay. So in this case, the mass of the compound is then 2,7 divided by 5 times 100. And that is going to give us 54%. All right, let's look at the next example. Limestone is mostly calcium carbonate. Jake wants to know how much calcium carbonate is in a sample of limestone. He finds that the sample weighs 3,5 grams. He then adds concentrated hydrochloric acid to the sample. The equation for this reaction is, and there they give us an equation. Make sure that it's balanced. And yes, it is. Now it says if the mass of calcium chloride produced is 3,6 grams, what is the percent purity of the limestone sample? Well, the key thing here is to use stoichiometry to determine the mass of the calcium carbonate. Because if we have the mass of the calcium carbonate, then that is the mass of the compound, which is what we need in our equation. So, first things first, we need our calcium carbonate equation, and there we go. So the two things that they give us information about is calcium chloride, which they say is 3.6 grams, and we want the mass of the calcium carbonate. So the first thing that we do is we find the mole. So we start there because that's where we have our mass. So we know that the mass is equal to 3.6 grams. My molar mass is going to equal to, so calcium has a molar mass of 40, chlorine has a molar mass of 35.5, and that's times 2 because there are 2 of them, and that is 70 plus 40, so that's 110 grams per mole. Okay, and we want the mole. And we know to calculate our mole, it's N equals to M over M. And then when we substitute, we get 3.6 divided by 110. So we have 0.03. I'm add another decimal place just to get a more accurate answer. And that's the amount of mole of calcium chloride that we have. Now, when we have this mole, we can now see how much mole of calcium carbonate reacted to give us this amount of mole of calcium chloride. So, comparing this one with that one, so we have calcium carbonate, and we are looking at calcium chloride, and they react in a ratio of 1 to 1. So if I have 0.033 mole of calcium chloride, how much mole do I have for calcium carbonate? And since it's 1 to 1, we have a mole of 0.033. And now we can calculate the mass. So my molar mass, calcium carbonate, is going to equal to 40 plus 12 plus 16 times 3. And that's going to give us 100. And we want the mass. So now we just copy our formula. We have 0.033 mole, a molar mass of 100. Remember to substitute. And then we have, when we change the subject, it's going to be 0.033 times 100. And that's going to give us 3.3 grams. Right, so now that we have our grams of calcium carbonate, mass of sample is equal to 3.5 grams. The mass of compound is equal to 3.3 grams, because we just calculated that. So now our percentage purity is equal to mass of sample divided by mass of compound by the mass of sample. So that is 3.3 divided by 3.5. And that gives us a percentage purity of 94.29%. Now do exercise 8-6.